And our next speaker, who's also joining remotely, is David Sidhu.
Okay, hi, can everyone hear me? Okay, I'm going to assume people can hear me. Cool, okay. So hi everyone, this is work that I've done along with Gabriella Viljoco at University College London. And the title of the talk is Effects of Iconicity in Recognition Memory, but a less jargony title might be something like Are Automatopoeia Easier to Remember? So the first thing I want to do is just to introduce this concept of iconicity. And this has to do with how one thing can refer to something else. So I'm going to use the example of these two signs, a sign for money, a sign for happiness, and just sort of unpack how they're referring to the things that they refer to. So first of all, this example here, this dollar sign, if you think about it, there is nothing inherently money-ish about it. It's just sort of this arbitrary connection that you kind of have to learn. If you didn't know what this meant and someone showed it to you, you probably have a really hard time guessing that this refers to money. This is what we call an arbitrary sign. On the other hand, if you think about this happy face, this is actually referring to the concept of happiness by imitating it, by depicting it. And this is a sign they would call an iconic sign. Now, while these are visual examples, you can also imagine that this happens in terms of sound. And this is how we start applying this to spoken language. So if you think about an example of a word like cat, there's nothing in the sound of that word cat that is cat-like, nothing in it that refers to a small four-legged furry animal. It's sort of like that dollar sign example, where it's this arbitrary connection. But you can also have words that are more like that happy face example, like the word meow, for example. So to some extent, this imitates the sound that a cat makes. So this is what we call an iconic word. So just to really hammer this home, arbitrary words are words that have no special relationship between their sound and meaning, and iconic words have sounds that imitate their meanings. And just for the rest of the talk, I'm going to call arbitrary words non-iconic, just to simplify things. Now, there's a lot of evidence that this concept of iconicity has psychological implications. So, for example, iconic words are learned earlier. They elicit different patterns in brain signatures, both in EEG and in terms of the areas that are activated when scanned with fMRI. And they're processed faster on word processing tasks like a lexical decision task. So I'm just going to focus on this last effect for one minute, because it's still a bit of a mystery why it is that iconic words are processed faster. And part of our motivation for doing this memory experiment was to try and get some insight into why this might be. So I just want to show you how we're sort of conceptualizing this effect of how iconic words get this benefit, how they're processed faster. So this is kind of a simplified model of how a word is processed. First, its spelling is processed, and this allows a person to retrieve its meaning. But there's also this more indirect route where you process the spelling of a word, which you use to retrieve its sound, which you then use to retrieve its meaning. And our idea was that potentially iconic words have these special links between sound and meaning, and that maybe this is why they're processed faster. So just sort of keep this in the back of your mind, because this is kind of the idea that we're going to be testing with this memory experiment that I'm going to discuss. So our big question is, will iconic words be more memorable on a recognition memory study? And if so, why? Is there any evidence that it's because of those sound meaning links? So the way we're going to go about testing that is with this levels of processing paradigm from the memory literature. And the basic idea is that when you get people to process words, you can direct them to do it in a shallow way by directing them to focus on the form of the word. So for example, thinking about how easy a word is to articulate by getting them to rate it from 1 to 5, for example. Or you can give them a deeper task or a more semantic task, like getting them to think about how pleasant a word is, and again, rating it from 1 to 5. And the general pattern is that when you get people to process words in this deeper way, this more semantic way, there's a benefit in memory. So memory for words encoded in the deep versus the shallow task tends to be better. Our idea was that maybe there's going to be an interaction between these levels of processing manipulation and iconicity. And the idea would be that for words like meow, for example, these iconic words, that maybe that difference between the shallow and deep encodings is going to be attenuated. And the idea there is that if you think of a word like meow, getting someone to focus on its form is to some extent getting people to focus on its meaning, because its form is carrying its meaning by depicting it. Okay, so that's the general idea of this manipulation. So in the study, we had people learn 80 words. Half of them were non-iconic, half of them were iconic. And this was based on previous ratings collected by Winter and colleagues, where participants rated thousands of words in terms of whether they were non-iconic or iconic along the scale. And these two groups of words were matched on all kinds of things that might have mattered. So things like length, frequency, valence, which is important because we're getting people to make a valence rating, and ease of articulation, which we're also getting some of the participants to do. So it was a typical recognition memory study where participants learned these 80 words, and they were put into one of two conditions. In one condition, they did this deep encoding task where they rated the pleasantness of each of these words from 1 to 5. And the other half of the participants were in this more shallow encoding task, where they just rated how easy each word was to articulate from 1 to 5. Then they got a memory test, which was a typical recognition task where they saw all 80 words once again, and 80 new words in a random order. And these 80 new words were themselves half non-iconic, half iconic. And for each one, the participant just said, is this old or new? Have they seen this word before? Okay, so I'm going to show you the results broken up in terms of these 4 measures that are typical in memory studies. And I'll just say that hit rate and false alarm rate were analyzed with mixed effects models, while D prime and criterion were analyzed with ANOVAs, because these are participant level measures. Okay, so starting off with hit rates. So this is how often a person correctly identified a word that they'd seen before as a word that they've seen before. So how often they're saying, yes, I've seen this word before, and being correct. And just to orient you to the graph, on this x-axis, we've got it split up by non-iconic. So these are words like cat, and iconic. These are words like meow. And the color is corresponding to that encoding condition, with the more shallow articulatory task in gray and the deeper semantic task in purple. So what we get here is no effective iconicity, but a main effective encoding. So better memory in the deeper encoding tasks. So not really surprised there. But in false alarm rate, so this is how often they mistakenly say that they've seen a word when they haven't. So when they see a new word, they say, I've seen this word before, and are wrong about that. This time we get an effective iconicity, but interestingly, we get more false alarms to the iconic words. So our first hint that there's actually maybe worse memory for these iconic items. Next, we'll look at D prime score, which is sort of an overall measure of memory strength, how well a person can distinguish between old and new items. And again, we get an effective iconicity with a worse memory for the iconic items. And then lastly, criterion C, which is sort of the threshold participants set of how much evidence they have to have before they say that they've seen this word before. And you can see that they set a significantly lower threshold for iconic items. So they're more willing to say, I've seen this word before if it's iconic. Okay, so just to sum up study 1, there was no interaction between iconicity and encoding condition. So sorry, if I go back for 1 second, you'll see that the interaction is non-significant for each of these measures. So no evidence that directing people to focus on the form of the words affected that iconicity effect. But we did get effects of iconicity where iconic words had more false alarms, a lower D prime score, and a lower criterion. So it wasn't really what we expected, but this was still interesting because we're seeing this evidence that iconicity is affecting memory, but actually making it worse. But at this point, we thought, is this just a context effect? So an effect of the list context. So the idea here is that when the participants learned the words, half of them were these weird automatopoeic words. So potentially, because they're seeing so many automatopoeia, that when they then at test see these new automatopoeia, they're going to be more likely to false alarm to them. So the way that we tried to rule that out was by using this mega study data. So this is data collected by Cortesian colleagues in 2 papers, where they tested recognition scores for thousands of words. And importantly, when participants studied these words, they were sort of normally distributed. So it wasn't the case that they studied half automatopoeic words. So if we get an effect of iconicity here, it can't be an effect of list context. So we had data for 4,000 items. And what we did was to predict memory performance with iconicity after controlling for a variety of things. And once again, we get these significant effects of iconicity on memory. So this time we do get an effect in hits. So iconic words are associated with a higher hit rate. Again, iconic words are associated with a higher false alarm rate and with a lower criterion once again. In this study, we didn't find an effect in D prime. So it does seem like iconicity is affecting memory, and it isn't just an effective list context, but we're still kind of left with this question of how or why iconicity is leading to the effects in memory. So our plan of using levels of processing didn't really pan out. That didn't really give us much insight. But our next idea was that maybe what's happening is that these iconic words aren't necessarily being remembered differently, but they just might feel more familiar at test. So this is coming out of this idea that responses on a recognition task are driven by two things. One, genuine recollection, so actually remembering seeing the item earlier. And then two, just how familiar an item feels. And these are two separate processes. And importantly, this feeling of familiarity is driven or affected by how easily an item's features can be activated at test. And so we think this might be where iconicity is playing a role. Because if you think about a word like meow, which is actually depicting its meaning, potentially because of that relationship, that depiction, it's making these features easier to retrieve. So this is what we're going to test in study 2, that maybe these effects are driven by these feelings of familiarity. So study 2 was the exact same setup as study 1, except that instead of just judging the words as old or new, they made this three-way distinction between recollect, familiar, and new. So if they actually had specific episodic details of encountering the word the first time, they were supposed to say they recollect the word. If they just think they have seen the word before, but can't really say why, then they say the word is familiar. And if they think that they haven't seen the word before, then they say the word is new. Okay, before breaking things down in this way, the first thing I'm going to do is just to show you what happens when we calculate false alarms, hit rates, and so on in this study. So I'm going to collapse these two into an old response and treat this as a new response to be able to do the same sort of analysis that we did in study 1. And instead of looking at study 2 on its own, what I'm going to sort of skip ahead to is just what happens when we combine studies 1 and 2. So now we have a nice big sample size of over 250 participants. So in hit rate and false alarm rate and D prime score, we get the same effects in all three. We get a main effective encoding condition and a main effective iconicity. So just to break down the iconicity effects, we get higher hit rate for the iconic items. We again get a higher false alarm rate and a lower D prime score. So again, worse memory for the iconic items. In criterion C, for the first time, we get an interaction between encoding condition and iconicity. And the nature of this interaction is that the encoding condition, whether they focused on articulation or valence, that has less of an effect on the iconic items than the non-iconic items. Okay, so setting that aside, what I'm going to do now is plot what happens when you look at these specific responses. So just look at the times that a participant said they've seen the word before and compare how often their response is that they recollect the word versus that the word is familiar. And I'm going to do away with the encoding condition for this plot because it didn't seem to matter in the analysis. Okay, so what I'm showing you here is on the y-axis, how likely they are to say that an item was familiar versus to say that it was recollected. And it's split up by new items, so items that they have not seen before, so these are false alarms, and items that they have seen before, so these are the hits. And the color is corresponding to non-iconic versus iconic. So you can see there's a main effective item status, much more likely to say that an item is familiar versus recollected if it's new. But the important thing that I'll just sort of jump to is that there's interaction, and the follow-up analysis shows that for items that they have seen before, when they say that they've seen it, they're much more likely to say that it's familiar if it's iconic. Just to rephrase that again, it seems that iconicity does lead to greater feelings of familiarity, but for the seen items, not the new items. Okay, now to sum up the results across all three studies, or all three analyses, in general, iconic words have more hits, false alarms, and a lower D prime score and a lower criteria. Now, just quickly talk about why this might be. So it doesn't seem to be an effective list context, but I'm sure that plays a role in the experiments. It can't be the entire story because of that mega study result. Another idea we had is that potentially iconic words are more similar in meaning to one another, and that's what's leading to these false alarms. So because they're all sort of sound related, maybe that's leading people to false alarm to them. And while that might be going on in the experiments, it again doesn't explain what's happening in the mega study. So there must still be something else happening. The other important result was that effects of iconicity didn't interact with encoding condition. So we take this to mean that this effect isn't really happening here. So getting people to focus on the sound didn't enhance these effects of iconicity. So it doesn't seem to be localized at the level of these sound meaning links. So potentially it's something special about meaning. And then the other clue that we might have is that words that people have seen before that are iconic tend to be more familiar. But this explains the hits, not the false alarms. So just to kind of sum it all up, people are more likely to say that they've seen a word before if it's iconic. We don't really know why yet, and we'd love to hear any ideas that you have. And here's our information if you'd like to get in touch at some point. Thank you.
Okay, I think we have time for one or two questions.
Hi, very interesting talk. I don't know if you can see me. Hi.
Hi.
I had a question about the mega study, and I was wondering what exactly. I'm kind of assuming you ran kind of a regression model on that, like a mixed effect regression with the control variables that you had listed, right?
Yeah, it was just a regular regression. It wasn't a mixed effects model. Just
Okay.
taking the average value for each word.
Yeah, because I struggle to see in the plot, like the blue lines all kind of look the same to me, and some of them were significant and others weren't. So I'm kind of wondering, with that much data, which like it's not that hard to find a p-value that's quite low. And I'm wondering whether you've tried to actually predict, like actually make a predictive model and see like how much adding the iconicity, I guess, helps a predictive model, right? Like actually predict the responses on held out data.
Right.
Does that make sense?
Yeah, absolutely. Yeah, it's not something we've tried, but that's a great idea. Thanks.
I think we have time for one more quick question if there's anyone. Okay, thank you to David.
Thanks.